In 10.1, we're going to be reviewing the area of parallelograms, triangles, and rhombuses. In addition to these three, we're also going to be reviewing the area of a trapezoid, rhombus, and kite. So first we have the area of a rectangle we know is base times height. So we're going to write that B times H. The area of the parallelogram is the same thing as the area of a rectangle. So again, we write that as B times H. And then we have the area of a triangle, which we know is 1/2 base times height. So 1/2 B times H. In addition to these three, we have the area of a trapezoid, which is 1/2 times the base 1 plus base 2 times the height. And next we have the area of a rhombus, which is 1/2 times diagonal 1 times diagonal 2. So we're just multiplying the diagonals and multiplying that by 1/2 in order to find the area. So next we're going to find the area of each figure. So here's some examples. So first we have a parallelogram. The area for the parallelogram is base times height. So when we're looking at the base, we have to look at the length of the whole base. So here, our base is going to be 12. So next we have to try to find the height, which is going to be the perpendicular line from the top to the bottom. So this line right here is our height. So most of the examples in the homework will give you the height, but for this one, we have to try to find it. So it tells us that this angle is 60, and if we have this angle that's 90, that means this one is 30. So we have a 30, 60, 90 triangle. So opposite of the 30 is 2. That means opposite of the 60 is going to be 2 square root 3. So here, our area, which is base times height, so it's going to be 12 times 2 square root 3. So all we need to do is multiply the coefficients, so 12 and 2. So our area is 24 square root 3. In the next example, we have our base. So if it tells us that this is 9, we know that this is going to be 9 too, since it's a parallelogram. So our base is equal to 9. And now we have to try to find the height. So we're going to drop a perpendicular line, which gives us a 45, 45, 90 triangle. I know this doesn't look like a 45, 45, 90, but it is, because it tells us that this angle is 45. So it means this angle has to be 45 also. So we know in a 45, 45, 90, if this is x and this is x, this is going to be x square root 2. So it gives us our hypotenuse of this triangle, which is x square root 2. So 6 is equal to x square root 2. So we just divide square root 2. And this is going to be our x. So we have x is equal to 6 over square root 2. Which we can rationalize this so we don't have the square root on the bottom by multiplying square root 2 over square root 2. So the square root 2 times square root 2 just becomes a 2 on the bottom. And on top we have 6 square root 2, which the 6 and the 2 then simplifies to 3. So we have 3 square root 2 as our height. and we know the area of a parallelogram is base times height, so we're just going to multiply 9 times 3 square root 2. So we're just going to multiply the numbers out front, so 9 times 3 gives us 27, and then we're just left with the square root 2 at the end. So the area of example B is 27 square root 2. Now going to the third example, example C, we have a triangle. So we know that the area of a triangle, 1/2 base times height. So here it gives us the base of 64, or 46. So 46 is our base, and 12 is going to be our height. So our area is 1/2 base times height. So we know that our base is 46 and our height is 12. So we have 1/2 times 46 times 12. So we can just multiply these two together first. So 1/2 times 46 would be 23 times 12, and then we need to multiply 23 times 12, which is 276. So our area of the triangle is going to be 276 millimeters. So next we have a rhombus. In rhombus ABCD, AC is going to be equal to 20 and BD is equal to 15. We can find the area in more than one way. So we're just going to look at A and B, and we can ignore C. But we know that the area is 1/2 times diagonal 1 times diagonal 2. So this second one will be 1/2 times diagonal 1 times diagonal 2. We also note that a rhombus is a parallelogram, so the area will be 1/2 base times height, which it gives us that 12 is going to be one of those base or height. So looking at this picture, we see that the perpendicular altitude is the height, which is 12. So if this is height, then we have to fill in the base. So the two ways to find area for a rhombus can be base times height or 1/2 diagonal 1 times diagonal 2. So next we can find the base. Looking at the top part here, we see that our base is 12.5, so we can fill in 12.5 there, and we just multiply 12.5 times 12, which is going to be 150. So that's one way of finding the area, and next we can do it by multiplying the diagonals and dividing that by 2. So we have AC is 20 and BD is 15. So diagonal 1 is going to be 20 and diagonal 2 is 15. So we just multiply 1/2 times 20, which gives us 10, and 10 times 15, which is 150. So there's different ways to find the area of a rhombus, and it gives us the same answer. Next, I'm going to do a couple of examples from the homework. So for 10.1 homework, I just highlighted the numbers that you have to do. And there's a couple examples that are different that we didn't look at in the examples in the PowerPoint, so I just wanted to do them in the video too. So if looking at number 2, the height of the rectangle in which the area is equal to 10x squared feet squared. So what we would do for this one is it gives us the area, and we know that area is equal to base times height. Since we're dealing with a rectangle, we can fill in this for A, and this is our base, so we put this in for B. So we can ignore the units, so we can ignore the feet squared and the feet for now. So our area, so what we put in for A is going to be 10x squared, and that's equal to base times height. So we have the base here, which is 2x, and we're trying to find the height, so we're just going to leave the height as h. So we want to get h equals, since we're trying to find the height, so we're going to divide this side by 2x and this side by 2x. Now we can divide the numbers, so 10 divided by 2 gives us 5, and then we have x squared divided by x, which just gives us x, is equal to, these are going to cancel out, so we have 5x is equal to h. So our height is going to be 5x feet. And if we wanted to, we could test our work and multiply the 5x by the 2x, and we're going to get 10x squared for our area. So we could just test it by multiplying base times height, and we'd get the same answer. So this is what the question's looking for. So it gives us the area and asks us to find the height. Next, let's take a look at number 3. So the perimeter of a square in which the area is equal to 169 centimeters squared. So in order to find the perimeter, we need to know what the side lengths are. So the area of a square is equal to the side squared. So here it gives us the area, so we have 169 is equal to s squared. So we can just take the square root of both sides, and we know the square root of 169 is 13. So 13 is equal to the side length, and we know that the perimeter is 4s. So all we need to do is take that side length. So when finding the perimeter, our formula is 4 times the side length. So we just take the side length and multiply it by 4. So our perimeter is equal to 52. So this would be our answer here. Okay, and the last one that I wanted to do with you guys is number 8. So it's looking for diagonal 2 of the kite in which the area is equal to 187.5, and it gives us diagonal 1. So we have to find the other diagonal. So we have to use the formula we know for area of a kite. So the area is 1/2 diagonal 1 times diagonal 2. Now remember, this is the same area that we use for a rhombus. So this is the area of a kite. So it gives us that the area is 187.5. So we just put that in for A. So we have 187.5 is equal to 1/2. And it gives us diagonal 1. So this 15 is equal to diagonal 1. So we just put 15 in for diagonal 1, and we're looking for diagonal 2. Now our goal here is to get it to be diagonal 2 equals. So we just have to divide what's being multiplied in order to get it to the other side. So we can multiply these two together first. So we get 7.5 times d2 is equal to 187.5. And then we just divide 7.5 by both sides. So these are going to cancel out, and we're going to get d2 equals 187.5 divided by 7.5, which we can use a calculator to find that one. And our answer is going to be 25. So I just wanted to do the problems that were not part of the examples from the study guide. So there's a couple more that are kind of like these from the homework. So you guys are still responsible to do these, but I did them for you, so you can just do it yourself and test your work and see if you get the same answer that I came up with. So this is 10.1. It's kind of like a review of what we've done before with area and perimeter, but it kind of expands a little bit more of what we've done before. Make sure you review the formulas for area when doing the homework because we haven't seen them in a while. So good luck.